Hello everyone, welcome back. And today we are about to discuss a very small concept called International Dateline IDL. I hope you have a clarity regarding the longitude. In the previous session, we discussed about the longitudes. They are the vertical lines, and longitudes are very much important in order to determine the time on the different parts of our Earth. Now, in continuation, we have a next topic or next concept which we are referring as IDL. Now, before we begin, let me make you clear about the two things. So, here you must be aware about the two things. The first thing is what? That the circle of illumination which is here. Here you can see in this particular image that on a one part of the sphere of, let's say, this Earth, we have a circle of illumination, means we have a day and we have a night. Similarly, and this is what, like, having a change. So this is the part of circle of illumination, means night, and here we have a for instance we have a day. So this is the first thing. All I want to say here is that we have a 180-degree longitudes, especially in 180-degree, we have a 0-degree longitude, and then we have a 180-degree longitude in each hemisphere, in Eastern Hemisphere as well as in Western Hemisphere. Let's say this 180 is actually overlapping, but just for convenience we are taking a reference of 180-degree west. However, 180-degree west and 180-degree east is a one single line. So we used to divide in this way, and this is what we used to refer as the Eastern Hemisphere, and this is what we used to refer as a Western Hemisphere. Now, similarly, at the same time, the Earth is rotating from west to east. Now, while rotating, the Eastern Hemisphere will remain ahead in time, whereas the Western Hemisphere will lag, will have a lag in terms of time. All I want to say here is that the Japan will see the sunrise first, if we take a reference in this particular situation, and if we see the USA, so that will be the you can say the location where the sunrise will be seen much lag, much behind as compared to the Japan. So it's because of this Eastern Hemisphere, it's remain ahead in time, Western Hemisphere remain behind in time. And here similarly the Earth is actually rotating. So in order to determine the time zone, especially we have a one line which is 180-degree east. I hope you remember the circle of illumination concept. Now with the circle of illumination concept, here if you see, for example, we have a 180-degree which is basically the longitude, which is actually the opposite side of prime meridian, that is 0-degree longitude. 0-degree longitude, it is the extension of 0-degree longitude on the opposite side of the sphere. So here on 180-degree east, we have what? International dateline. So international dateline is actually an imaginary line. It is an imaginary line which is drawn at 180-degree, where we have a like a clear-cut distinction between the Eastern Hemisphere and we have a Western Hemisphere here. And if you cross this particular international dateline, there will be a variation in terms of time. How? Let's see. Suppose we have a Earth shape and we have a arrangement in this way. We have a 180-degree. This is what the international dateline we are referring. Now, just take a reference of circle of illumination. Remember, I hope you remember. Now, this part is exposed towards the sun. Now, when this part is exposed towards the sun, here what we can say that we have a day part, and behind this one we have what? The darkness, or let's say the night. For a one given time period, here we have a circle of illumination. So circle of illumination is here in Alaska and circle of illumination is here in Siberia. So there is a day in Alaska or there is a day in Serbia, for example. It's because of circle of illumination is working in that way. At a given point of time, only the 90 longitudes will be covered by the circle of illumination. Rest of the longitudes will be behind, or let's say they will be under the influence of night time, under the darkness at a given time, while Earth is rotating continuously. So that circle of illumination which is actually covering the Earth's surface will going to change even at the pulse of 1 degree longitude, even at the pulse of time period as well. So here we have a, for example, international date line as an imaginary line. It is a zigzag line. It is not a straight line. It is not a straight line, just because, like, just to distinguish the regions, the areas, those who are actually in the confluence of this international date line, so just to make a separate kind of time zone. You'll have a more clarity in some upcoming slides. So we have this part which is under the circle of illumination towards the day part. So what we can say, that day is here, day in Alaska, and day is also there in Serbia. But I hope you remember, Eastern Hemisphere will ahead in time and Western Hemisphere will lag in time. So lag in time means behind in times. Here we take a reference of date. So this is the line which is actually separating dates, not time. So here if you see this 180 degrees, so it is basically the international date line. It is separating the dates among the hemispheres. So here we have a Eastern Hemisphere, I hope you remember, and here we have a Western Hemisphere. Western Hemisphere and Eastern Hemisphere. Now suppose there is a one person who is in Serbia, and if this person cross this international date line and he go all the way to Alaska, so now the person is actually crossing the international date line. Now the time is same, okay, yes, time will be having some sort of variation based on the longitudes. I hope you remember, 1 degree longitudes will equal to 4 minutes. So suppose, let's say we have a almost 30 to 40 minutes or more than that even. For example, we are taking a reference. So there is some sort of time difference, but we are talking about the date. So if a one person A is actually crossing the international date line, means a person is moving from Serbia to Alaska. So here I would like to make a one more reference in terms of directions. So here we are taking a universal east direction, and here we are taking a reference of universal west direction. So this is the direction, and this is the hemisphere, Eastern Hemisphere and Western Hemisphere. I hope you remember. Again, I am recalling that this 180 degree, the part which is behind this board, that will be the prime meridian, and this is what the entire Eastern Hemisphere from 180 degree while moving like this and moving behind on 0 degree, that will be the Eastern Hemisphere. Similarly, from that 0 degree to this 180 degree, we will have what? Western Hemisphere. Likewise, if this person is moving, this A person is moving from Siberia to Alaska, means this person is moving towards eastward. This person is moving eastward. So if you move eastward, there will be what? There will be a loss. There will be a loss of time. So while moving eastward, there will be a loss in time. Loss of time, you can say. How? Let's take an example. Suppose there is a 8 August in Siberia. This is the Eastern Hemisphere, will remain ahead in time, and this is the Western Hemisphere, will remain lag in terms of time, we can say. So here we will have what? 7 August. We will have what? 7 August. This is what the role of international date line, to separate the dates. Now this person who was there on 8th of August, now he crossed the international date line and he moved back 24 hours. He moved back by 24 hours and he entered into 7th August. Suppose you are having this number 8. If I say loss, that means what? 7. So this person is actually losing in terms of time. Now if there is a reversal, means if the same person, let's say if there is another person who is about to move from Alaska to Siberia, so in this case, when the person is moving from Alaska to Siberia, here you can see that there is a westward movement. So whenever we have a westward movement, or if you cross the IDL while moving westward, as a result of this, there will be a gain in time. See? Gain in time means the person who was here on 7th of August, now he moved back by 24, he moved forward by 24 hours, and he is there in Eastern Hemisphere, entered on this 8 August date. So here there is a moving back to 24 hours, here there is a moving forward to 24 hours. That resulted into the gain, this resulted into loss. So this is what with respect to the international date line. So if you cross international date line respectively, you will have loss or you will have a gain in time. Moving ahead. So if you cross IDL westward, means this way. If you cross IDL westward, there will be a gain. So if you cross IDL westward, there will be a gain in time. And if you cross IDL eastward like this, so you will have what? Loss. You will have a loss. So crossing IDL eastward will result into loss a day. If you cross eastward, you will have what? Loss of time. So this is what with respect to the international date line. Now, if you cross this IDL, and if there is a crossing of IDL respectively by 15-degree longitude, so there will be a 1 hour. There will be a 1 hour gain or 1 hour loss in time. If there is a 1 degree variation, so that will lead to the 4 minutes either gain or loss if you successively cross the IDL, or let's say the longitude after the IDL. Suppose you are crossing from 180 degree to 179 west, 178 west. So you will have a loss of time respectively by 4 minutes. Vice versa, if you are moving from, let's say, Alaska to Siberia, you are crossing the international date line, and now if you are on 179 east, 178 degree east, so you will have a gain in terms of the time respectively by 4 minutes, or let's say 8 minutes in this specific case. I hope there is a clarity about the international date line, about the loss, about the gain in time. Now, based on these set of longitudes, based on the longitudes, we actually divide the entire Earth in terms of what? In terms of time zones. So here you can see that we have a longitude. So we have this 0 degree. This is the 0 degree here, which is being known as prime meridian, or it is also being known as what? 0 degree longitude. Greenwich line, Greenwich mean time, you might have seen. So this is what the Greenwich mean time. It is also being known as like UTC, universal time as well. So from this particular line, we will going to measure. This is what the Eastern Hemisphere, this is what the Western Hemisphere, right? So here, suppose if there is a, like we have a 15 degree variation, suppose there is a 12 noon on 0 degree on, let's say, Greenwich line. So here we will have what? Almost 1 p.m. when you move by 15 degree. So on, if you see India respectively, so India is ahead from this 0 degree or this Greenwich mean line by 5.5 hours. Means if there is a noon on Greenwich mean line, during that same time period, there will be a almost 5 p.m. That would be the timing in India. Respectively, if you see, so here we have a Western Hemisphere which is behind in terms of time. Here you can see we have a minus, means behind in terms of time. Here you have a plus, means ahead in time. So this is how, in order to have a transportation convenience, navigation convenience, air navigation, we can say, administrative convenience, we can say, to have that convenience, we actually divide our Earth's surface in different longitudes, and yes, in different time zones. Usually countries, those who are there, they actually adopt a one single time zone in order to have an administrative convenience, but the countries, those who have a vast east west expansion, usually adopt more than one time zone. So here, if you see Russia, basically, so it will have some sort of around 7 time zones. USA, if you see, so USA also have some sort of 4 to 5 time zones. It's because the east vast expansion means, here if you see, the one part of Russia is under the confluence of 165 degree east, and the another part of Russia is somewhere, we can say, 60 degree. So you can see the variation. If you want to see the variation, we have 100 degree longitude difference almost, and if you multiply it by 4, you will have a 400 minutes. That is the variation. If a person is standing here and if a person is standing here, there will be a variation by 400 minutes. It's because of the vast expansion, east west expansion of continents or countries. So when we have this kind of expansion, as a result of that, there will be a huge time difference. In order to avoid that time difference, usually countries adopted what? Multiple time zones. Here if you see India, so we are not that much vast as compared to Russia, or let's say as compared to the USA. Vast means the longitudinal variation, the eastern part as well as the western part of Russia. You can see here the variation in terms of the longitudinal aspect. So here we have a 165 degree. Here you can see we have a 165 degree, and here almost we have what? 60 degree. So there is a variation of 100 degree, and if you convert in time, multiply by 400 minutes, you can imagine that if a person who is sitting here, of a person who is communicating from here, there will be some sort of delay, or even there will be a delay in terms of sunrise or sunset, likewise. All right, so this is how the longitudes, the relevance of longitude is there in order to determine the different time zones over the Earth's surface.